right? So once you identify the PDE is of the form Lagrange's linear equation, right? The first step what you have to do is you have to write it in the auxiliary equation form, or it is also called as simultaneous equations or subsidiary equations, right? So you have to write dx by p, that p is nothing but the coefficient of small p, and dy by q, that q is nothing but small coefficient of small q, and r is nothing but the right hand side function, right? So then your work is to solve this simultaneous equations, right? Your work is to solve the simultaneous equations, right? There is a procedure is there why we are doing like this, but for your level it's no need, right? So whenever you identify that PDE is of the form PP plus Q equals to R, right? Then you have to transform that thing into this. While we're transforming this, remember this is a partial differential equation, but when you transform this into substitute equation, right, then it became an ordinary differential equation with the dx and dy and dz. So it is not dou x, it is dx, dy and dz, right? Okay. So how to solve this? For this also there are some not standard procedure, but you have to use your common sense, right, to solve these equations dx by p plus dy by q equal to dz by r, and you have to find two equations of the form u of x comma y comma z and v of x comma y comma z. So your ultimate aim is to find these two functions by solving these equations, right? That only we did in the last class. That only we did in the last class, and we also solved did one or two problem also. So today we will continue, right, with some more problems, and then we move on to the next section. But unfortunately, I lost one class last week, right? So I'm a little bit fast because in offline classes, we already come to the end of the first unit, right? And also one more thing I'm telling you, try to join the class as early as possible, right? So 12:20 class over means try to join within 5 minutes for the next class. Maybe some network issues are there. For me also some network issues there. But right, somewhat you have to try to join within 5 to 10 minutes, right? Don't join like this 12:30, 12:35, right? So now I will show you one problem based on this, right? So in this problem, have we discussed this problem last class? Anybody remember or not? Have we discussed this problem last class or not? Because I discussed this in the offline class, I know. Have we discussed this problem? X into y square minus z square. Nobody
No, sir.
huh? If you remember, then okay. If nobody remember, then I can explain.
No, sir.
Okay, right. Right. So first thing we have to identify what you have to do is, right, whether there is only one P and one Q is there. Yes, there is only one P and one Q is there. Apart from that, only function of XYZ, XYZ, and XYZ. So from that, you can identify that this is in the Lagrange's equation form. Right? Once you identify it is in the Lagrange's equation form, you have to write immediately the subsidiary equation by identifying what is P, what is Q, and what is R. Right? So dx by p, p is nothing but x into y square minus z square, that you have to write in the denominator. And q, what is q? Coefficient of small q, that is y into z square minus x square. And what is r? That is in the right hand side, right? Once you write all these three things, then you have to try to solve it. Here only the problem comes, right? There are some functions which are easy to solve by just do the cross multiplication, right? Remember, if it is dx is there, then you should have only functions of x here in this side, then only you can integrate. A function of x into dx only you can integrate in the ordinary differential equation. But unfortunately, y and z is there. Similarly, in dy, y is there, but unfortunately, z and x is all there. So you can't integrate directly. Or if you do even the cross multiplication, you take this term here, and x, you can take this x square with the dx and take this y square with the dy, but still that square may create some problem, right? Because even if you do the cross multiplication and take these two terms for solving, right, but z is not at all there in dx and dy, right? So what we have to do, right, that you have to think. And now I will teach you there are certain methods which are not there you never studied before, right? So listen carefully what we have to do. So if you have to solve this, so previously last class we see one or two problem where we take any two ratios because there are three things are equivalent, 1, 2, 3. So in these three things are equivalent, we can take any first two or 1 and 3 and then we try to solve. But here all three is having x, y, z. So cross multiplication and taking only two, right, and solving is not possible. So we have to do some other idea, right? So here only you have to use certain things called as method of multipliers. Method of multipliers. What is the meaning of this? Right? You have to multiply some number variable uh, uh, or the constant arbitrary constants, right, with the numerator as well as the denominator, with the numerator and denominator, and try to make this as 0, right? Try to make this as 0, right? So for example, if you see this, if you multiply x and x in the numerator and denominator in the first term and y in the second term and z in the third term, then automatically this term becomes x and this term become x square. Similarly, this term become y. Just if you multiply numerator denominator with x, y, and z, this becomes z and this become z square, right? And now you just see x square into y square is there, minus x square into y square is there. Similarly, minus z square into x square is here, minus z square into x square is here, and plus z square. See, minus z square x square is there and plus z square x square is there. Similarly, finally, we have minus y square z square is there and plus y square z square is there, right? So if you add all these things, automatically everything cancel out each other and you get 0 in the denominator, and in the numerator you have x dx, y dy and z dz. So what is the idea? You have to multiply a variable or a constant, but here you are taking a variable, right, x, and multiply x in the numerator and the denominator of the first term and y with the second term and z with the third term, and then we add all the equivalents. We add all the equivalents, that is x dx plus y dy plus z dz, right? So if you add all the numerators, automatically you have to add the denominators also. Right? But one thing is there in mathematics, right? If a by b is equals to c by d, then a plus c divided by b plus d is also equivalent to the this ratios, right? So even if you add, right, the ratios remain same and is equivalent to the original one also, right? So now if you do that, it becomes x dx plus y dy plus z dz, and in the denominator we have this term, right? So and automatically it becomes 0, right? So usually if the denominator becomes 0, you think that, oh, denominator is 0 means so the term become infinity because the denominator is 0. It's not like that. Here what we are doing is we are simply telling the total differential, right? So whatever is right in the upper is nothing but the total differential, right? So this total differential becomes 0, right? That is differentiation of something is becomes 0. If differentiation of something becomes 0 means the term should be a constant term. That term should be a constant term. So from this what you are getting is, you don't think denominator is 0, it becomes infinity. It's not like that. What it represented is this total differential x dx plus y dy plus z dz should be 0. Should be 0. That is the meaning. That is the meaning, right? So theoretically that is the meaning. So don't think it denominator is 0, so it is equals to infinity. It is not ordinary number, right? So upper side both the numerator and denominator are nothing but the differentials, right? If it is a number, then if the denominator becomes 0 means then it become infinity. But here it's not like, it is a ratio of the differential, right? So if the denominator is 0, the numerator also, the total differential should be 0. So in that case, right, x dx plus y dy, that is this term, right, x dx plus y dy plus z dz should be equals to 0, right? So once you find this, then right? Then you can do the integration, because once you get this total differential is equals to 0, now you can easily integrate both sides, right? You should integrate both sides, and you can write this as x dx, right? Y dy integral z dz equals to integral 0, and automatically we will get integral of x is x square by 2, integral of y is y square by 2, integral of z is z square by 2. That only you are getting in the next page. On right hand side, you may ask, sir, only a only will come, because integral of constant is, integral of 0 means integral of constant. Integral of constant is integral of 0 means you have to put a arbitrary constant. Then why you are putting a by 2, right? Remember, if a is arbitrary constant, a by 2 is also a arbitrary constant. That is putting because in order to remove this 2, in order to, because 2 is coming in the left hand side in all the terms. So even if you're not putting 2, you take this 2 outside and take this 2 in the right hand side. If a is arbitrary, 2a is also arbitrary, a by 2 is also arbitrary. So we just mentioned the right hand side is a arbitrary one. So whether we mentioned as a or a by 2 is immaterial mathematically, right? So whether we are putting a by 2, right? And once we put a by 2, automatically the left hand side is and right hand side is are become cancelled, and we get a nice relation x square plus y square plus z square equals to a. And this is nothing but our equation u of x, y, z. I already told you, using that three equivalents, you have to find two functions. One is u of x comma y comma z equals to a. Another one is v of x y comma y comma z equals to b. Once you find the two equations, right, and then the function having the two equations, the function here you can see the function having the two equations is nothing but the general solution of the given PDE. What is general solution? General solution is nothing but a solution of the PDE containing an arbitrary function. Since the given PDE is of order 1, so the general solution containing arbitrary function, one arbitrary function, that is called phi. But what are the arguments of that arbitrary function? That only we are finding as u and v. That only we are finding as u and v. So that arbitrary function, that is nothing but the general solution of the given PDE having some arguments u and v, having some arguments u and v. That arguments can be found by solving the simultaneous equations, right? So now we found only u, but now we have to find v also, right? We have to find v also, but how to find, right? So previously what we did, we multiply x in the numerator denominator and y in the numerator denominator and z in the numerator denominator, and then we add. But now what we have to do now, previously it is dx by x, dy by y into this, dz by z into this coming. Now I just rewrite as whatever x here, I take that x here, so nothing wrong, right? Dx by x into y square by z square is same as dx x by y square minus z square. Similarly, dy y by z square minus y square. So what they are doing now, very simple, in this equation, right, they are taking this term as a separate term, and they are writing this as dx by x, and this term they are writing in the denominator y square minus z square. Similarly, dy by y they taken separately, and then the z square minus z square they are writing in a separate manner, right? So just rewrite, right, the three equations like this. Once they rewrite like this, now obviously you can see this y square and this y square is cancelled out, this z square and this z square are cancelled out, and this x square and this x square are cancelled out. So automatically it become 0 when if you add all these three equations. So if dx by x plus dy by y plus dz by z, if you add the as in the numerator and we consider this term in the denominator, then the denominator become 0, right? Again I'm telling here the denominator is 0, then don't think it is equals to infinity, not like that, right? It is not like that, right? That we are telling, we are only the total differential is 0. So if total differential is 0 means that is dx by x plus dy by y plus dz by z, it should be equals to 0. And then we integrate this. So integral of 1 by x is, we know, log x. Integral of 1 by y is log y. Integral of 1 by z is log z. And here 0 is there. So when we integrate, we have to put an arbitrary constant. And here we put log. Again the same rule, right? because left hand side you can take log out. Log a, log x plus log y plus log z can be written as log of x, y, z. So if b is a arbitrary constant, log b is also arbitrary constant. So I am putting simply log b and then cancelling logarithm. Don't think log is a number. So log is a function operated on x, y, z, and here log is a function operated on b. But the theory says if log values of two things are equivalent, right? That is if log uh, if log a is equals to log b, then a equal to b. So is the rule is there. Similarly here also, similarly log a plus log b can be written as log a into b, right? So this is one rule. Another rule is log a plus log b is equals to log of ab, right? So using this two what can say it, yeah, rule in logarithms, they're writing log of x plus log of y plus log z, log x plus log y plus log z, they're written as log of x, y, z. If addition is coming here, right, all the terms should be in the multiplication here. And here still b is arbitrary, log b is also arbitrary. And if log a equals to log b, logarithm of two things are equivalent, then the two things should be equal. If log a equals to log b means a should be equals to b, right? And again this is a function of x, y, z, right? So and we call it as v. So there are two functions we found now. One is x square plus y square plus z square equals to a, that we call it as u. And similarly now x, y, z equals to b, that we call it as v. Now the general solution of this problem can be written as, right, phi of x square plus y square plus z square comma x, y, z equals to 0. That is phi of u comma v is equals to 0. U comma v is equals to 0. Right? So this is the idea or procedure to solve Lagrange's linear equation. Right? Very simple procedure. Sometimes you have to do the cross multiplication and taking x dx on one side and y dy on the other side, and you can solve. And for certain type of problems like this, right, there you have to use the method of multipliers, right, multiplying some terms in the numerator denominator and add accordingly and make it the denominator 0, right, then you will get a nice one. So similarly there are different methods are there, right? So what are the problems? Last class we discussed two problems and this problem. An examination point of view important, so that I but since you have a notes with you, right? So my suggestion is, or my thing that advice is, right, at least to do one or two problems by yourself in Lagrange's method, by because I already sent the class handwritten notes there. There are also some problems are there. Or if you have a Max 3 book having PDE, right, you try to solve one or two problems, right? I will solve one more problem for you, because there are some problems, right, are very important in examination point of view. So I will solve one more problem for you. So but my request is, right, try to solve by yourself at least one or two problems, not only for this topic, in all topics, unless otherwise if you're not solved by yourself you can't able to understand, right? So I will solve one more problem in this, try to understand. Okay, so can you see my screen now? The new problem. Hmm?
Yes, sir.
Right? Can you see the screen now?
Yes, sir.
Right.
Yes, sir.
Okay.
Yes,
So
sir.
now the problem is x square plus y square plus yz into p plus x square plus y square minus zx into q equal to z of x plus y. Right? So again obvious, it is in the Lagrange's equation form, where p is this term and q is this term and r is this term. Then straight away you have to write dx by p, dy by q, dz by r. Right? So here also again, right? So cross multiplication not problem because x, y, z is there in all the three equations. But here the idea is different because here you can't do anything, adding this won't work because something in power 2 and something in power 1 and zx is there, yz is there, right? So you have to do some other technique to solve, right? So that will come to your mind only if you practice it, right? So here what they are doing, no, they are taking only the first two terms. They are taking only the first two terms and they are try to find the difference of it. Why? Because if you find the difference of that, automatically that x square y square term will cancel out, right? So, and only thing, the remaining thing is when it dy by dx minus dy is nothing but yz minus of zx, right? Yz minus of zx. Then automatically this minus and minus become plus. So automatically become yz plus zx. So z is common in both the terms. So you take z outside, then y plus x is there. Y plus x is there, right? So remember, this is only you are getting by taking only the first two terms. Only taking the first two terms. You are not at all touching the third term. But obviously, you can see that, right? If you the denominator of the term now you are getting after subtracting the first two equations, the denominator is same for the third one. Here also z into x plus y is there. There also z into x plus y is there. So now you can equate these two things directly. I already told you if a by b is equals to c by d, then R is equals to E by F, right? So A by B equals to E by D equals to E by F. Then if you find A minus C divided by B minus D, that is nothing but this term. Then this term also equivalent to all these three terms, so that we can able to equivalent this to dx, right? So a minus c divided by b minus d, again it is equivalent to a by b, a c by d equals to e by f, so that we can equate that last term, that is e by f, that is nothing but dz by z into x plus f with this thing. So now automatically the denominators cancelled out easily. And in the numerator we have dx minus dy is equals to dz. Now you can integrate directly both the left hand side and the right hand side. Automatically we will get x minus y. And z comes this side, it becomes minus z and is equals to, you put the arbitrary constant a. Right? That value you are getting here, x minus y, z comes this side, x minus y minus z equals to the arbitrary constant a, right? So this you get and you take as u, but that is not only sufficient, you have to find one more relation, v of x y z, right? For that again they are using some tricky idea. What we did in the last problem, they multiply and divide x with the first term and multiply and divide with y with the second term, right? And then what happens, right? Just check, right? This is x into x square plus y square. This is y into x square plus y square. So that two terms is here. X into x square plus y square is here. Y into x square plus y square is here, right? Then this is x into y z. This is minus x into y z. So these two terms will cancel out. So in the numerator we have x dx plus y dy, and in the denominator we have x plus y into x square plus y square. But whatever you multiply, you add, right? Again, what are the ratio you are getting in the last line? Again, that is equivalent to the original equivalence. What is the original equivalence? Right? You are taking only the first two terms and you just doing x dx plus y dy. But even after adding, the ratio is equivalent to the third one, that is dz by z plus xy, right? So that now after doing all these things, all this simplification, but still this ratio is equivalent to the ratios given when we write dx by p equals to dy by q equals to dz by r. Because from that only we derive this, right? So equivalence, no change. It is something like 2 by 4 or equals to 1 by 2. Whether you can write 2 by 4 or 1 by 2 as a ratio, both are equal, right? So similar idea. So now what they did, no, they simply cancel out x plus y and x plus y, right? And now they have a nice x dx plus y dy with x square y square in the denominator and dz with z, right? Now it is possible to integrate, right, both sides, right, by doing one tricky idea, right? So this also a little bit vague to you, but this type of things are there, right, in differential integral calculus methods, right? In schools you may not study, but now you have to study, right? So what they have is x dx plus y dy in the numerator and x square plus y square in the denominator. So now what they are doing, no, they're simply multiplying 2 both in the numerator and in the denominator. So automatically the denominator become 2x dx and 2y dy, and the denominator is 2 times x square plus y square, right? Now what you have to do, know, you have to consider this x square plus y square as some, you can say some s, or I can say sw, right? You take this x square plus y square as w. So 1 minute 4 is coming on 1 minute. Right? Okay. So here what we have to do, you have to multiply and divide by 2, right? On both numerator and as well as in the denominator, right? And then we have to rewrite in this form. This is very, very important. How to rewrite? If you take this x square plus y square as w, then if you differentiate normally, then what will come? You will get, if you differentiate x square, you will get 2x. Then if you differentiate y square, you will get 2y, right? So if you differentiate this, then you will get 2x dx. Similarly, if you differentiate y square, you will get 2y dy. So 1 minute. Hello? சொல்லுங்க. நான் ஒரு 10 மினிட்ஸில் ஜாயின் பண்ணிக்கிறேன். சரிங்களா? நான் ஆன்லைன் கிளாஸில் இருக்கேன். நான் 1:10 முடிஞ்ச ஜாயின். Right. Okay. So it is 2y dy, right? So if you take this denominator x square plus y square as w, then your dw is nothing but 2x dx plus 2y dy. And you just check, this is nothing but here, right? So whatever the denominator is there, if you differentiate that denominator, you will get the numerator. So it is something like dw by w. It is something like dw by w. If you take x square plus y square as your w, then what are the numerator? 2x dx plus 2y dy is nothing but dw. It's nothing but dw. So what is 1 by w or 1 by x? That is log x, right? So you consider this as a variable, right? Integral of 1 by x. Integral of 1 by x dx is log x. 1 by x dx is log x. But in place of x, w is there. So you have to put log w. But what is w? Again, w is nothing but x square plus y square. X square plus y square. Right? So these are tricky things in integral calculus and our integration methods or differentiation methods. You should know all these things. Right? Because previously you studied only the formulas, but you should know the integration differentiation method. So here the idea is you have to take this as w. You take this as w, then automatically this become dw. This become dw. So when you integrate this, this is log w, that is log of x square plus y square. Similarly, integral of 1 by z dz is log z, and they put the arbitrary constant also log c, and they take this log z on the other side, then you will get the term. Otherwise, they do one simple thing. They take this 2 on this side. So it becomes 2 log cz. Okay, this is not correct. So this is only 2 log c, right? So if you take this 2 here, so I just write If you take 2 this side, this is 2 log C 2 right. So the right hand side will be equal to 2 times log Z plus log C. Right? Now, two times log Z can be written as log Z square. Right? This is also a property of logarithm. If some constant is multiplied with log of a variable, then that constant, whatever multiplied constant, can go to the power of log Z. Right? Suppose if it is 3 log Z means it become log Z cube. Right? So here 2 log Z, so it become Z square, and 2 log C is nothing but log C square will come, but again log C or log C square, whatever it may be, it again a arbitrary constant. So they put log C square as B, but Z square will come, and then they cancel out all the logarithms, and they cancel out all the logarithms. So left hand side x square plus y square is there, right hand side z square, because this 2 goes to that side and make it as log z square, and then here log, why you are putting square on b, right? So there is no need to put. If b is arbitrary, b square is also arbitrary, so putting squares or multiplying with constant in the arbitrary constant won't work anything, right? It remains same, so that they represent the entire thing as simply b. So arbitrary constants are only a representations, right? So even if you see write c or c1 or 2c, arbitrary constant is arbitrary constant, right? That can be found only if you put some values for x, y, z. Otherwise, you just assume as arbitrary constant is there, that is represented by some letter. So here this is written by b, and logarithms are cancelled out. It is not cancelled out like a number, it is like an operator. If you operate log on both sides, if it is equivalent, then the variable also should be equivalent. That is, if log a is equals to log b, means a is equals to b. So in that manner, x square plus y square, it should be equals to some constant times z square, or if it takes the z square other side, you will get a nice equation with x, y, z. That is, we call it as b, right? And now you take these two things. What is the first thing? First thing is this one, x minus y minus z. That you take it as u, right? And now the second thing. What is the second thing? This one. This you take it as v. And then you have to write the general solution as phi of u comma v. Phi of u comma v is equals to 0. Right? So this is the way you can write the general solution of the given PDE. Right. So I hope, right, this will help you to understand Lagrange's equation. So on now the next section, that is the final section of the first unit, that is solving higher order PDEs, right? So that I will take in the next class, because now I have a meeting at the end of this class.